So let's look at these questions. It says, below are three chemical reactions. Determine the coefficients and number of moles required in the reactions. In addition, identify the type of reaction. So let's see. In this first reaction, we have iron 3 oxide reacts with fluorine to create iron 3 fluoride and oxygen. So let's identify any ratios that we might have. So first, we are going to look at iron. We have 2 on this side, and then we have 1 on this side. So it's going to be a 2-to-1 ratio. Then we're going to look at oxygen. Oxygen, we have 3 on this side, so it's going to be 3. And then we have 2 on this side, so it's going to be 2. Then we have fluorine, so we're going to look at fluorine. We have 2 on this side, and we have 3 on that side. And that's all of the atoms that we have. So now we're going to use this to help us find them. So let's take, for example, we can have oxygen. So let's say there are 3 on this side and 2 on this side. So a number that satisfies that ratio could be 3 times 2, 6. So let's see. So let's see, 3 right here, and maybe a 2 right here. So let's see, it's going to be 6 oxygens and also 6 oxygens. So then that means we're going to have 4 of these. So 4 irons, and then we're going to have 4 irons again. So it's going to be 4, but that means they're going to be 4 times 3 because of this subscript. Shows that there's 3 fluorines in this compound. So that means it's going to be, what times 2 equals 12? So it's going to be 6. So so now we can check this. For 4 irons, 6 oxygens, 12 fluorines, and 12 fluorines. So now we've balanced it. Now we need to identify the type of reaction. So we can see that a single element, fluorine, replaces the oxygen in this chemical reaction. So it's going to be, apologize for my handwriting, but it's going to be single replacement, because it is a single atom or element. Right now it's diatomic fluorine, replacing another single element, which is diatomic oxygen, in this compound. So now we're going to move on and look at this next reaction. So we see that we have hydrogen fluoride reacts with sodium hydroxide to form water and sodium fluoride. So let's see. Let's start up some ratios. So hydrogen, there's 2 hydrogens on this side, and then 2 hydrogens on this side. So it's a 2 to 2. So now, since they're both the same, we can just simplify that down to 1 to 1. So the ratio is 1 to 1. Now we're going to look at oxygen. So we have 1 oxygen on this side and 1 oxygen on this side. So it's also going to be 1 to 1. Then let's look at sodium. We have 1 sodium and another sodium. So now that's going to be 1 to 1. And then finally, let's look at fluoride or fluorine. So we can see there's 1 fluorine on this side and then 1 fluorine on this side. So it's 1 to 1. So using this, we can see that it's just going to be a 1 to 1 ratio. So it's just going to all be the same. So it's just 1, 1, 1, and 1. So look, so now let's just come back and check our work. So we have 1 hydrogen, 2 hydrogens, 2 hydrogens, and then we have 1 fluorine, 1 fluorine. We have 1 oxygen, 1 oxygen, 1 sodium, and 1 sodium. So this is correct. And then we're going to see that we have this. So hydrogen fluoride, whenever it's in an aqueous solution, it is known as hydrofluoric acid. So it would be more appropriate to put an aqueous right here. And then this could be solid or aqueous. And so now it's going to form water and a salt. So that means that this is a neutralization reaction. So this is a neutral reaction. So wait, let me just... Sorry about that. So it's a neutralization reaction. And yeah, now we're going to move on to the last one. So now we're going to move on to this one. We have methane reacts with oxygen to form water and carbon dioxide. So now we're going to set up some ratios. So we're going to look at hydrogen. We have 4 hydrogens on this side, and then 2 hydrogens on this side. So it's going to be 4 to 2, which is going to simplify down. You can divide both sides by 2. So it's going to be 2 to 1. So it's a 2 to 1 ratio. Then we're going to look at carbon. We have carbon here and then carbon here. So it's just going to be 1 to 1 ratio of carbon. Then we're going to look at oxygen. We have 2 oxygens and then 1 oxygen, 2 oxygen. So it's 2 to 3. So we're going to have 2 and then 3. So hydrogen, carbon, oxygen, hydrogen, carbon, oxygen. So it's all the chemicals or atoms that we have in this reaction. So now we can go in here and start simplifying it. So let's look. 4 hydrogens. So this is the biggest one that we have. So we have 4 here, and then we have 2 here. So let's just put a 1 here, and then a 2 here, because of that 2 to 1 ratio we identified earlier. So that leaves us with 2 oxygens, and then another 2 oxygens. So that means we're going to put a 2 here as well, because it's diatomic, so this is 2 times 2 is 4. So now we have, and there's 1 carbon, and there's 1 carbon, so we're going to put 1. And so now let's check our work real quick. So we have 1 carbon, then 4 oxygens, 2 oxygens, and then another 2 oxygens, so it's 4 oxygens. And then we're going to look at hydrogens, 4 hydrogens, and then 4 hydrogens. So this is the balanced chemical equation. And so now we can see that there was a fuel, which is methane, being combusted with oxygen to yield water and carbon dioxide. So we didn't know that this is a combustion reaction. So now we've finished all of these questions, and hopefully this gave you some insight into how to identify and label the coefficients, balance them for chemical equations, and thank you for watching.